Now, this is what's going to be on the test 2. I mentioned this yesterday. I just want to make sure everyone's got that. And then you're gonna have a take-home problem that you're gonna staple to the back of the test on Saturday. And also don't forget there's that extra credit equation balancing problem as well. So if you go into files and just do a search for extra credit, it'll come right up. And there are 3 versions, not versions, but 3 copies of it. Okay. Now what's not on the practice test today is these 2. I was telling you last time I moved the units around. These 2 are on another practice stuff. But for sure, we're gonna be, when you've seen them in here, balancing equations, conversion, simple gram to gram stoichiometry, similar to the dry lab. And then this is the take-home problem on limiting reactants, which went over yesterday. Focus on the first problem that went over yesterday. Went over 2. The second one got confusing because there's a whole bunch of weird conversions. Let's focus on the first one. Okay, is everyone okay with that? Now, on the periodic table, I'm going to give you a periodic table. I'm going to ask you to find the following. That would be the, let me just write this down. Okay, and then on Lewis dot structures, I'm going to give you 2 formulas. One should be simple, and the other is going to require you to do 2 alternate structures for it. Okay, then balancing equations. Give you an equation to balance. And simple conversions like going from 4 grams of water, how many molecules is that? Those kind of questions. Then stoichiometry is going to be gram to gram, gram to liter, liter to gram. And I'll give you the unbalanced equation. Okay, so assume all equations in this class are not balanced. And I'll try to post the take-home problem today. It'll be in files test related. Okay, are there any questions about? Yeah. Correct. Correct. Everyone hear that? Lab 12, Lewis structures only. And don't do the sulfur. And the reason for the sulfur takes on different versions because it's lower down in the periodic table. Now you'll get into that more in your 1A class or 3A class, depending on which one you take. Okay, so let's look at the practice test. How many moles are in 114 grams of vinegar? I'll give you the formula for vinegar. We need to first calculate molar mass for vinegar from the periodic table. And you're going to be using the periodic table that's on the test. So molar mass for that is going to be 4 hydrogens. That's 101 a piece, so that's 4.04. Two carbons, those are 12.01 a piece. So that's 2402. And we have two oxygens. Those are 16.00 a piece. Okay, so that's vinegar. All right, so we're starting with 114 grams. So to get to mold, we're going to use the molar mass that we just calculated here. So it's going to be grams cancel, and 4 sig figs, right? Yeah, 4 sig figs. The opposite problem is how many grams are in 125 moles of battery acid, which is H2SO4 sulfuric acid. So we need to do H2, so that's 2 H's, 4 oxygens, and 1 sulfur, what sulfur, 35, something like that. 207. Okay, now we're starting with 125 moles. Cancel. And we're looking at 3 sig figs. Your next chemistry class, this is one acid you're going to have to know, sulfuric acid. Okay, how many atoms? How many? That's Avogadro's number again. How many? How many atoms? Notice I capitalized the word atoms to draw your attention to that. How many atoms of hydrogen are in 9 grams of water? Water is 2 hydrogens, 1 oxygen. Okay, now we have moles. Now we're going to go to Avogadro's number to determine the number of molecules. Molecules, not atoms yet. Now, how many atoms of hydrogen are in 1 water? 2. Just like how many wheels are on a bicycle? 2. How did you get that? You multiply 2 times the number of bicycles. If I told you there were 10 waters, how many H's are in there? 20, because it's 2 times 10. Oh, wait. It's that recipe that we were talking about. Okay, so now we have one more conversion factor that's getting us H's per 1 water. Okay, so let's grind this thing out here. Problem, if you forgot to do the very last step, the two H's over 1 water, I gave you partial credit. But just read these carefully. Okay, what's the mass in grams of 26? I don't know. Should have been 2.6. But anyway, 26 times 10 to the 12 molecules of water. Okay, so we're starting with numbers. We got to get to moles. That's Avogadro's number. Now we're gonna go from moles to grams. Okay, so those are typical conversion problems. Basically, you want to do unit cancellation. Keywords are things like atoms versus molecules, keywords like atoms versus molecules again. How many, thinking Avogadro's number. Okay, so the next one here, we've got 50 grams of HNO3, which is nitric acid, is consumed. How many grams of oxygen are produced? Okay, so step number one is balance the equation if there's a reaction. Is this balanced as written? Let's see here. We have an H, N, and an O. Okay, we've got one H on the left, two on the right, one N, three, and five. Okay. So you guys have any suggestions where we're going to go in this? Now, one thing about this problem, if you don't know where to start, punt. And this is what I mean by punt. Let's just put a 2 here. Okay, and we have to take inventory again. So that makes that 2, 2, 6. Okay, so let's fix the nitrogens. We have 2 nitrogens. 2 nitrogens. That kicks the oxygens up to 4, 5, 7. What do you think? Now let's say you're stuck right now. What I recommend you do is do that. Okay, let's put a 3 there now. Things didn't work out with a 2, let's try a 3. Okay, so we have 3 H's, 2 H's, 3 N's, 1 N, 9 oxygens, 5 oxygen. Oh, is there a ledge there?
You thought you could just fly through it in the window.
Oh, it hit the window?
Yeah.
Oh. Then it's okay then, right? Okay, so 3 for the bird then. Okay, all right, let's do the nitrogens there. Let's make that 3. Okay, redo inventory. So that's 2 hydrogens still. How many oxygens we got? Okay, we've got 6, 7, 9. Now this works out fine, except for H's don't work out. What do you think we should do now? How can we, huh?
Double it.
We've already doubled it. Double what? The HNO3 on the left?
Once you find like, the biggest common factor, he's talking on it, type thing.
Uh-huh. Well, H is coming 2, right? So let's make this an even number on the left. Okay, so that makes that. And it gives us 12 O's, 3 M's, O's. Okay, what about oxygens? Okay, we got 12 on the left. We have 8, 10, 12 on the right. So I did that on purpose. And that's the way I would do this problem, exactly the way we just did it here. Just things didn't work out, numbers were weird, just start over. Okay, so step number 1 is balance the equation, which we did. All right, so let's go on to, oops. Okay, so we're starting at 50 grams of HNO3. To calculate grams of O2. We need to end up with O2 over here on the right. First thing we need to do is convert to moles. Okay, so that's H is 101. Nitrogen is and 3 oxygens, so there's 16 apiece, so it's going to be 48. Okay, so we're looking at 2, 9, 13. Yeah, 2, 0. Yeah. The ratio of nitric acid to O2. So O2 is gonna be in the top. Nitric on the bottom. So we've got from the balance equation. Everything's moved all over the place here. So we've got. This is a pain. Okay. 8. General numbers over here.
Well, H was 2 on the right.
2 waters.
For water, it was originally 5 on the right. Oh. Yeah, 2.
2.
2 is the finished product.
Yeah, you can temporarily, yeah, exactly.
Is that what we have to do here? I think.
Yeah, exactly right.
This
So-
is just from the video. I was taking notes.
Hmm?
Just from the video, I was taking notes. I'm just saying, maybe is that what we have to do for this one? Same type of thing? Maybe.
Because it's.
Well, as long as we've got it balanced, that's the main thing.
Okay.
And then, if you balance it with a fraction, that's fine. But just don't leave it.
Yeah.
Yeah, exactly like this second part there. Yeah, exactly right. So, it doesn't matter how how you get it balanced.
Okay.
Just, even if it's twice when you're all done, for example, you ended up with 8, 8, 4, and 2.
Mm.
It will still balance. It's just, it needs a factor of 2 to be taken out.
Okay, so doing this would get the same thing, is what you're saying?
Hmm?
Doing this would get the same thing for that.
Yeah, because you're gonna end up with a fraction on the oxygen,
Okay.
but then you just clear it by multiplying, like you said there, multiplying by 2.
Okay.
Okay. All right. So the oxygen to nitric acid is what? 4 to 1. And I'm going to get rid of this. Put it away. Okay, now we need to convert to grams. So that's going to be 32 grams per 1 mole for O2. So we've got grams cancel, moles cancel, HNO3 cancel, leaves us with grams of water.
the four sig figs? Because we're starting with four, isn't it?
Oh, yeah, to be four.
Because that should be.
Okay, so as far as partial credit goes, how would I break this down? If you didn't balance the equation correctly, but the rest of it is fine, I would take off 2 points. Okay? Normally on a multiple choice test, if you didn't balance it right, but you set up right, you'd still get it wrong, totally wrong. So, again, that's why I don't do multiple choice tests either. My students do better. Everyone in the beginning says, oh, we love multiple choice tests. No, you wouldn't love chemistry multiple choice tests. There's no partial credits, either right or wrong. So, all right, does everyone understand this guy? Now, your dry lab, you're gonna do a whole bunch of these. A whole bunch. And I want you to do problem 2 last. I even balance the equation for you. A real pain to balance that one. Okay, and then there's one more problem here. (16.00) and it actually is. Because of all the elements there, they standardize, they used to standardize on carbon, but in the last 20 years, they've standardized on oxygen. It's exactly 16.0. And there's no way for you to know that.
The other ones would not be.
Correct. The other ones are, but they're not. Cool. Well, oxygen would be infinite. And also the coefficients from the balance equation also infinite. Because those aren't measured, those are exact. So that's infinite as well. So what we're looking at is 4 sig figs. And that's an interesting issue too, is oxygen versus carbon. A long time ago, they put carbon at 12.00 and then made everything relative to that. And I don't know why they changed over to oxygen, but they did.
You know, on the periodic table, it says 16.00. So that's also four sig figs. You
Yeah.
wrote it with 3.
But to answer her question though, it was it's 16.000000. Because they just defined it that way. Okay, and then there's another problem here. This is going to be like your take-home problem. This is a two givens. So we need to do 2 equations, figure out which is the limiting reactant. And then we need to figure out the excess of the non-limiting reactant. So first thing we do is balance the equation. So let's do it over here so I don't have these weird problems. Okay, so let's balance it. What can you say about that? Is it balanced? Yeah, already balanced. Always check though. Okay, so let's start with the iron first. Okay, 7.
Why is there like an S in parentheses on the question?
Okay, her question was, what's with the S and the L's? S means solid, L is liquid, and G is for gas. And sometimes you'll see, instead of S, you'll see PPT, which is short for precipitate. And those we're going to get to shortly. But for now, you don't have to put those down.
Two L's in parentheses there after iron.
Okay, that is going to be covered when we cover nomenclature. The 2 means it's a charge of +2. And that's, I'm going to give you a sheet of ions. And you're going to see iron has 2 names, iron 2 and ferrous, iron 3 and ferric. And they changed over to this parentheses, because then you don't have to worry about is us lower than ick, and it fixed it. However, the problem is food industry still goes on the old naming. So they have ferric and ferrous. Agriculture, ferric and ferrous. Everyone switched over except no one switched over except for the chemists. And I mean, it's clear that it's a +2, but and ferric and ferrous is alchemy stuff. I mean, it's that old, that nomenclature.
Right.
Okay, and then we see, so we're looking at how much the FeS is formed. Okay, everything is 1 to 1 to 1. Okay, first thing we need to do is do a grams to moles. So this is for iron. Grams to moles. Okay, iron is now a lot of you say, why do we have to put the 1 to 1 in there? Because then the Fe doesn't cancel. That's why we put it in there. And now we need sulfur. Okay, so because the iron showed a lower amount, it's the limiting reactant. Okay, if iron is the limiting reactant, that means S is in excess. After the reaction goes to completion, how much iron is left over? Now, this is something you need to remember. Limiting reagents get totally used. So that means we have 0 iron left. And how much sulfur is left? Well, we need to calculate how much sulfur is used. So that to do that, we start with the limiting reagent, which is 6, the iron. Going to go to the sulfur now to see how much we use. It's 1 to 1. Sulfur is 3207. This will be how much the sulfur is used against the limiting reagent. So we've got, so to calculate how much is left over, we used 438 of it, and we started with 867. So you have to subtract now. So that's how much sulfur is left over, because we used 438 grams of it. That's why we had to subtract down here. Now this is going to be similar to your take-home problem. The only thing, I'm going to put a yield in there as well. Let's say the yield on this problem was, let's say 2 grams. Okay, we should have got 12 theoretical. So that's 2 over 12 times 100. Okay, so that is very similar to your test.
On the top.
The vertical from the actual and then divide them. That's what we do in percent error.
Oh, since.
And last week, do that calculation.
So we're only calculating percent yield for these problems. We're never gonna be calculating percent error for, these problems in the past.
That would be, when you're doing strict yield, it's what you got versus what you should have got. Now, a percent error problem would be, you should have got this, this is what you got. You did. Then you do theoretical minus actual over theoretical times 100. That's calculating percent error. This is percent yield.
I'm just gonna be used to these.
That's the second one. We're not gonna do it. It's a simpler way to go. It's just looking at actual versus theoretical. Okay. Okay, in lab, you're gonna do that actual versus minus the theoretical over theoretical times 100, because in lab, you're doing error analysis. This is just straight. How much did you get versus what you're supposed to get? Okay. Any more questions? All right. That was a very good